Alright guys,
I'll get out of the way.
we're going to get started guys.
But we don't extensively use it. There's so many legacy applications that I think. I'm talking calculus perspective. We were unable to join the club.
Thank you everyone. There's going to be a few people trickling back in. Hey, for those who've managed to stick around this far, thank you so much. It's actually really appreciated. Now we're getting on to the hardcore container stuff. This session, you don't need any tools. You don't need anything installed. You need a machine that's got a browser, or a phone that's got a browser. Don't do it on the phone, honestly, it'll be good stuff. What I want you to do, we're going to do this in a couple of pieces. First, we're going to get you provisioning your container hosts, because that takes a little while, and then I'll talk about what we're actually doing, a bit about containers and stuff. So if you can just go over, there's this URL at the bottom of the screen, or a QR code. Head over to that URL. That will take you to the workshop. So I'll give you a few seconds to head over there. That's just a GitHub repo, just a GitHub README. And we're going to start running down through that. We're going to first provision the container cluster, which is a Kubernetes cluster. And then I will talk to you about what it all is, what we're doing. Just to get a bit of a feel. Oh, by the way, I'm Dan, by the way. Just, It's good to meet you all. Hey, and thanks to all the other presenters, Nick and Rory over in the other room for organising all this stuff, because I know it's really hard, and Daryl for kindly coming and live streaming this stuff. It's, they work pretty hard getting this stuff done, and it's really appreciated. Gotcha. Okay, so once you've done that, you should have come to this nice little page, which is something like this. So you should have, what I would recommend, you have your Azure portal on one side, on one tab, and this document on the other. What we're going to do is we're going to create a Cloud Shell. Anyone here never heard of or used or not used Cloud Shell? Anyone not used Cloud Shell doesn't know what it is? Cool. So I'm actually surprised. There's usually most people haven't heard of it. Cloud Shell is basically a Bash or a PowerShell shell that runs in the browser, runs inside the Azure portal, and it's got pretty much everything you could ever want installed in it. It's got the Azure PowerShell commandlets. In the PowerShell one, it's got, in Bash, it's got Azure CLI, it's got Kubernetes, kube control, it's got Docker tools, it's got. Oh, sorry guys. No. I've lost my mouth. The QR code is if you were going to follow along on your phone, which you really don't. But yeah, the QR code's that URL down the bottom there. It's a 9. It's a 9. Bad font. Bad font.
That last one?
Yeah, that last one is a 9. That's pretty embarrassing font.
It's a lowercase 9 or uppercase?
Lowercase 9.
So comedy as supplied by Daryl. That's a lowercase. That's a 9. Thanks a lot, man. So anyone not got to this URL? GitHub should have a nice README or a terrible README, depending on your opinion of my writing. So we're going to skip down to, we want to go part 1, opening our Cloud Shell. So we're going to go into the portal and we're going to create ourselves a Cloud Shell. Now if you've never done it before, it'll ask you a couple of questions. It takes about 2 or 3 minutes to provision. It's actually using containers in behind the scenes. So that, if you've never used containers before, as soon as you do this, you're using containers. So we're going to open a Cloud Shell, or create one, and then that'll allow us to use that permanently we can store files in there, we can store scripts, we can run code, everything. So we're going to use this to provision our container cluster, and then we're going to talk about containers. So head over to step 1, and let's go over, and the first thing we're going to do is just click this little Cloud Shell button at the top of the portal. So I will be doing this along with you guys. I'll just make this a little bit easier to see. So I'm going to click this little Cloud Shell button, and it's probably going to tell me you just deleted your Cloud Shell. So what it's doing here is actually requesting. There's a bunch of container servers over and around the world that all they do is run Cloud Shells for you. So I deleted my Cloud Shell, and if you delete your Cloud Shell, it gives you this error and then says I'm going to have to create a new one. So it's just restarting mine. You won't get this error. You'll get a message saying like this.
Do you want a PowerShell or a Bash?
And we're going to do Bash. I am actually a PowerShell person, but I thought I'm going to learn. I'm going to get. Yeah, I know. I'm going to get my Bash skills up for this. So.
Modules for PowerShell.
So, but everyone, you know, I like to multi-skill. So, if you're a Bash person, you'll be right at home. If you're a PowerShell person, you'll be sad like me. So, if you click, this is going to ask you which subscription. What it's doing is creating a storage account for you. So you can put files that storage account will persist. You can actually mount it as an SMB share, mount it on your work machine, and share files. So you could, you know, might have a bunch of files, a bunch of scripts you like to automate processes in Azure, chuck them on your machine, mount that drive, you know, map that drive, stick them in here. So you can run some advanced settings that allow you to choose where you put your storage account, but I'm just going to go create because we just want to run through this reasonably quickly. Now, this session we're going to run through it's a big workshop. I highly doubt we'll get through all of it in 90 minutes. So do feel free to continue on. The last step of the workshop will clean everything else up because you're provisioning container clusters that cost about $2.50 a day to run, and if you want to save your credit, you might want to delete those. And the last step of the workshop is to delete those. So now it's creating my cloud account, my Cloud Shell account. So has anyone got to this point here? Got a Cloud Shell, a little big, nice big black screen. It's a bit hard to see there, so I'll try and make that. This large.
Oh yeah.
Bit easy to see. So there's my Cloud Shell. This is just a Bash shell. I can switch to a PowerShell one if I want by just dropping this PowerShell thing down here and changing that. That will then spin up a Windows container, and I'll be running standard Windows in behind this. But we're going to stick with Bash. So next thing we're going to do is we're all going to create a cluster, a Kubernetes cluster. It's going to be public. It's going to be on the internet. So the first thing we need to do, we have to give it a name. So, and we can't all give it the same name, you know, bootcamp test, because that would not be unique. So I want you to all come up with a name for your cluster that's not likely to be the same as anyone else. It's a URL, so don't put, you know, semicolons and whatnot in it. So I personally am going to, if we look back at our workshop, back over here, oops, technical user fail. So I'll go back to the workshop here. All that didn't work so well. It's now flipped it to a different window. Andy. So we now have our storage account, everything's all set up, our Bash is done. So we're going to move on to part 2, which is we're going to create an Azure Container Service. So step 1 is to launch your Cloud Shell, but you're already in your Cloud Shell, it's already provisioned, so we don't need to launch that. You can actually launch Cloud Shell by going to shell.azure.com, and it'll give you a full screen shell. So you don't have any of the, you know, you can maximize your shelling experience. So what we're going to do is we're going to come up, step 2 is come up with a name. I'm going to use Dan's ACS, but you should not use Dan's ACS, because when I provision mine, we'll have an argument. So come up with something like, you know, my super awesome ACS, but don't use that.
Do it before he does.
Do it before, yeah. If you do it before mine, you can ruin it, and I'll come up with something else. So I'm going to do the same. But what we're going to do is we're just going to assign this to a variable. And the reason why we're doing this, we don't have to do this, it's just otherwise I have to remember what I called it, and I'd have to put in my example scripts, have to put your, replace your text here. So this just makes it easier so we can reference that name in all the commands we're going to run. So I'm going to do that the same thing by saying name equals Dan's ACS. Now this is pretty much all the typing you're going to have to do. The rest of this is just going to be copy and paste. So now I've got a variable called Dan's ACS, and you will have yours. And we're going to go back to the next step, which is we're going to use something called the Azure CLI, which is a awesome command line tool that can do anything. Anything you can do in the portal, it can do. In fact, it can do more things than the portal can. Often there is certain functions you can only do in Azure CLI. So, I just figured out what I was doing wrong. Okay, so step 4. Now we will speed up. Step 4 is we're going to use this command here to create a resource group. So this is using the Azure command line. Fail there. Copy this and just paste it in your Cloud Shell. So I'm going to right click, paste. You could of course use Control V. And what it's doing here is this command is saying AZ group, meaning resource group. It's a little bit fast there. Scroll up a little bit. So it's saying AZ group, resource group, create the name, and remember I assigned the $ name to a variable, RGP, and the location is East US. So and that'll happen pretty quickly, and if we actually go to the portal and have a look what's going on, you'll actually see that resource group will have created if you go over and I'm not going to refresh the screen. So you can see helpfully, it's actually behind my. You can see there's. Where is it? There it is, right there at the bottom. Dan's ACS RGP. Now we'll start to speed up through this process a little bit. So next we're going to copy the next command. So if we head over to back to here, this is the command that's going to create our cluster. Now this will take about 15 to 20 minutes, depending on a number of things. Copy the whole line, it's quite long. And I'll talk to you about a little bit about what it's going to do. I'm just having control failure here. So, hopefully that's the whole command. I actually think I didn't copy the whole thing. So if I didn't copy the whole thing, it's going to give me an error.
Yeah, you missed something.
Yeah, I did. Yes, I missed the end of it, so. So you know what, having as little success in copying an entire line as I am?
Yeah.
Control Shift right.
Control, Shift. Aha, okay.
And keep doing it. Should keep copying. Control shift left there. Yeah.
There we go. Okay.
Just use a mouse, bro.
Fortunately, okay. So now you should have had more success than me, and you will now be provisioning your cluster. So this is going to take a little while. We're going to go do some other stuff. We're going to go through the presentation quickly. Okay. All right. So we're just going to quickly go through this. I'm going to try and get this done in 30 minutes, just so you can focus on the workshop. Can I just get an idea? Who here's used containers before, or running them in production, or cool? Who here's heard of containers? Sweet. Oh, well, we'll start with that. We'll start with some of the easier stuff. So, what are containers? Does anyone remember 1997? Honestly, I don't. In '97, Starship Troopers was released. And that's an awesome movie. Yeah, I know.
Really?
It was an awesome movie. But data centers were filled with these. Hundreds and thousands of these hot beasts. They were physical machines. There was no such thing as virtualization. You wanted a new machine, you had to buy one of these and stick them in your data center.
Look at the handles on those things.
Yeah, I know. They were
you could,
heaters
like,
too.
you know,
You could. They were awesome.
Get
Look
fit
at
lifting those things.
3.5-inch disk drive.
Yeah.
Top of the line gear. So,
How much disk space? 40 megs?
enough for everyone, right? No one ever needs more than that. So 1999 rocks around, and VMware releases a product. It wasn't actually it was I think it was for virtualizing Intel IA86 chips, not x86, and that was the start of the virtual machine revolution. So that was where we said we're going to virtualize hardware. We're going to allow one virtual machine run a bunch of operating systems. We get much greater density in our data centers. So that was how it was. For 15 years, everyone was virtualized. Everything, data centers still are virtualized, and that's not going to change for a long time. But that's where the operating system multiple operating systems share a single piece of hardware, or a single machine. Containers allows us, or Docker came along and they said, let's see if we can all share the same operating system. So when you get an app, let's see if we can all we have 5 apps all sharing a single operating system, with them all thinking that they're using the same operating system. They're on their own. So this was the concept of virtualization of the operating system. So you have an operating system that runs, Windows, Linux, whatever it is. You have a kernel, and then you usually have a container orchestrator, and you have multiple apps, and they all have no visibility on each other. They don't know they exist. It allows you to get greater density on that virtual machine. It allows you to have the same app run on that same operating system, but multiple versions to roll over to that new version. So, and if you find that new version is a bit fun, you can roll back. They still need to be on different ports, but we'll talk about that in a bit. So that was 4 years ago that Docker came up with this. And since then, a lot has changed. So here's a bit of a comparison between the two scenarios. We still have an operating system, we still have virtual physical hardware, except we can basically use more of that resource to run containers because we have less of that overhead. We don't have 5 copies of the operating system. We have 1 copy of the operating system, and all containers can share that. So, one of the other cool things about containers is that the container you run on-prem can be run in the cloud. It can be run on your desktop machine, and it will always run the same way. So yeah, it can run in physical or virtual servers on Linux, on Windows Server 2016 Plus. That includes Windows 10 or things like Azure Stack. And obviously the cloud also. So Microsoft provides so many different ways of running containers. the one we're going to talk about today is is Azure Container Service, but there's lots of other ways, and you really got to choose the one that's going to work for what you were trying to do. I would, if you want to run Bing for some reason, you would choose Service Fabric, or if you want an Xbox Live, Xbox Live is running on Service Fabric. But if you were, say, running a batch process for doing some financial stuff that runs once a week, you might use an Azure Container instance. But Azure Container Service sort of gives you a bit of a middle ground. It orchestrates, it does a whole lot of stuff for you. And what you've just deployed is one of those. And hopefully that is still going. What it's doing is provisioning some virtual machines. It's provisioning the networking in between them and all the things that takes care of all of that for you. So there's two kinds of container hosts. There's Linux container hosts, which run Linux containers. And there's Windows Server containers and Hyper-V isolated containers. Both of those run on Windows Server 2016. But either way, no matter which you choose, if you choose to run Linux workloads or Windows workloads, you're going to have Docker on that host. Docker is the thing that makes containers easy. Containers existed before Docker, a long time before, in fact 20 years before, but they were almost impossible to use or provision. It wasn't until Docker came along they said, we can make this easy for you. There is one other exception here, and that is, as of, I think, Windows 1709, Windows 2016, 1709, you can run the Linux containers on Windows Server. But what actually happens behind the scenes is you use Hyper-V to provision a really, really, really thin Linux container host, and then runs your container inside that. But it's transparent to you, but it's pretty cool. So basically you can just pick a Windows Server 2016 VM and run whatever you need, whatever workloads you need on it. Hyper-V isolated containers is a special case where if you need to run a workload that's really needs to be secured, needs to be isolated from everything else, what that does is runs another lightweight hypervisor for you, and then runs your container in that hypervisor, and you get a whole lot of features like the container's not sharing the same operating system and stuff, but you won't get as much density, and they're a little bit slower.
Question. You can't run Windows containers on Linux. Correct. So Linux host,
you can't run a Windows container on a Linux host, but you can do it the other way around. But it is some trickery. It's not pure.
Native.
Yeah, it's not native. It looks native, but it's not. So, Microsoft loves Linux. Everyone's heard that by now. Well, hopefully everyone's heard that by now. So, all of that, we got container images. So, when I'm talking about a container, I'm talking about a container image. So, a container image basically is the bits that you generally get handed to say, run this in a container. I want you to make me a container built out of this image. And those images are usually, they could be provided by the development team or by a third-party provider. Like, if you've got, something like Splunk, you can run Splunk in container images. If you want to run Jenkins or GitLab or any of these other products, they all provide container images that say, right, here's a container with our product, just run that. Container images are built out of layers. So you start with a base image, which usually contains the operating system. And there's really only three flavors. There's lots of Linux versions. You find Alpine is probably the most common. Lots of Linux versions. But in the Windows space, if you want to run a Windows Server container, you're going to use Server Core or Nano Server, depending on what you want to run. Nano Server is about, you got 400 megs nowadays. I can't remember. It's pretty small, whereas Windows Server Core, that base image is 9 gigs. But say you're running 10 containers using Windows Server Core on a single container host, you're only going to use 9 gigs for that base image. You're not going to run 10 times 9 gigs of operating system files. So you usually take a base image and then you start building stuff on top of it. So as a development team, you'll take a base image and then you'll say, I need to add my application files to that base image, and I will just give you the difference between the base image. I'll say my app runs on Windows Server Core, and I give you an image with 50 meg image that just has the differences that you would add to that. And you don't have to worry about any of this. This is all happens behind the scenes. You know, the team will give you an image and you'll use it. So as I said, each image only stores the differences. When I'm talking about an image is just all the files, the registry settings, pretty much everything about the operating system that might be different when someone gives you an app. So where do we store these images? You know, they are a custom file format. Basically, a container registry is where you're going to put them. Now you've got really a bunch of different choices, but you can store your container images on the host that you build them. So that could be, you know, if you create your container image on your Windows 10 desktop, your container image will be stored there. But usually you want to push it somewhere so that other people can have access to it. You know, you developers, you know, your IT pros, you guys will be given the URL to the image. You'll be told, look, it's in our registry, go run this. Run me 10 of these, keep them running. So they'll push it to Docker Hub, possibly, but that's a public or private registry. So if I push an image to Docker Hub, by default it's going to be available to everyone in the world, and I might not want that. So in Azure, you've got this concept of that, or this product called ACR, Azure Container Registry, which allows you to basically create your own container registry. It's private to you. It's all AD integrated, so you can, you know, grant access based on your AD credentials. So it's got some good stuff in there, but it's completely private. You could make it public to other people, but then you have to give your AD credentials. Yeah, don't go there. So if you want to do public images, use Docker Hub. If you want to do private, use Container Registry. So what is the workflow? How are we doing with time? Yeah, we're doing all right. So what is the workflow with creating an image, creating a container? Basically, someone builds the container. They use Docker to build it. It's usually built by development teams, but it could be built by you guys, or it could be just pulled off the internet. You don't even need to build it yourselves. Then it's published to a registry. Then you use an orchestrator nowadays to orchestrate the deployment of that image to your hosts, to your container servers, so it's running and available. And this is where Kubernetes comes in, which is what we're going to talk about pretty soon. And then once the orchestrator has orchestrated it, those containers start running, and they'll keep running until the orchestrator tells them to do otherwise. So here's the meat of this: is orchestrators and Kubernetes. Because previously, earlier on, Docker was the only thing. You would just say, look, Docker, run me an image, run another one, run a container, run a container, run a container. That's cool, but it's not very, it's not as good as saying to an orchestrator, I want you to keep my system running no matter if I bring containers down, if cluster nodes fall off the internet, if I want to upgrade containers. I just want you to keep this running, and I want you to scale it for me. I want you to scale it, auto-scale it. That's what an orchestrator does. It provides these load balancing features and all sorts of great tools.
So like a cloud orchestrator for VMs, in this case, Azure?
Kind of. I mean, it's like, say, it's almost building a network plus workloads in a single box. It's like virtualization of everything. It says, so you could say, I've got 5 container hosts, and I want to run a load balancer with 15 containers here and another load balancer over here. And these hosts could be, you could have one in the cloud, you could have one on-prem, you could have one up in Google, and you can spin your workloads up anywhere, and they'll just keep running. You can do some pretty amazing stuff with these orchestrators. They are really, amazing. So The one we're going to focus on is Kubernetes. I mean, Kubernetes was developed by Google, and it's free and open source. There are two others that there are more than two others, but we will mention those in a little bit. But the one we're going to talk about is Kubernetes. Microsoft has pretty much jumped in on that one, so Azure is all about the Kubernetes these days. It runs anywhere, and this is the cool thing. If I get good at running Kubernetes, if I know how to run Kubernetes, I can run it on-prem, I can run it on my desktop, I can run it on other providers, other cloud providers, wherever I like. I can even have my Kubernetes controller over here in Azure, and I can be running workloads in AWS or Google Cloud and on-prem, and I can orchestrate between them. Really cool. And as I said, there's other orchestrators. You'll have maybe come across DCOS, which is also Apache Mesosphere, and Docker Swarm, and Kettle, which is part of the Rancher suite. They're all awesome, but you'll find that Kubernetes is getting the most love and getting the most popularity these days. Especially, it's very proven. It's, Google uses it, so they're good at that sort of thing. So this is what a Kubernetes cluster looks like. You have this thing at the top here. You've got the scheduler, which is it's just basically a VM, and that, or a bunch of them if you're doing highly available. And the job of that thing is to tell all the agents, these nodes, what containers to run and how to move traffic around between them and orchestrate your systems. So in our case, we're actually building this. It's building right now. It might have even finished for some of you. We're building one master, which is this little blue Kubernetes symbol at the top, and two virtual machines, which are nodes. And they're going to run our containers. We'll talk about what pods and kubelets are in a moment. So, as I said, the first thing we've got is the master. And all the master does is say, I'm going to schedule workloads on the agent. I'm going to make sure that if one of your agents, which is the container host, goes down, that the workloads it was running are moved to another agent. And it will also say, you sent a message to this agent over here. You want to connect to a web server on this agent. It's not running on that agent. It's running over here. It will transfer your traffic across the other agent to the container where it is running. So you don't have to worry about where your containers are running. You just say, I want to send traffic into this port, this website, and it will redirect it through the load balancers, the internal load balancers, make sure your traffic gets there, and make sure your containers always run. So the master, it's like the scheduler. It's the brains of the operation. It can be made highly available. So you need two VMs to do it, or more than two. Actually need 3 or 5. But we're only doing one. And it is a container host itself. But we won't go into too much detail on that because we want to get into the workshop. So nodes, they're container hosts as well. They can be Windows or Linux. You can have a container cluster, a Kubernetes cluster that has Windows hosts and Linux hosts, and you can run both workloads, and the master will go, oh, you want to run a Windows container? I'll send that over to the Windows host for you. You want to run a Linux container? I'll send it over to the Linux host. So you don't have to worry. As long as you've got both, you've got nodes that support your workloads, it'll work. You can dynamically add them and remove them from the cluster. So you're running low on capacity, add a couple more nodes. You can even run add ACI, Azure Container instances to your cluster. Again, it's something for an advanced class. And they run a kubelet, which is basically just an agent that says, I will take commands from the master and execute and make sure your pods work, your containers are all running. And it also has one or more pods. So what are pods? Pods, fancy, is just a unit of deployment. What it actually means is it just says, I'm going to have a container running, or more than one container, and this is sort of like a single thing that I've deployed. I can scale this. This pod might run one container web host, web server. But I want my pod to be able to scale to 5 containers across multiple nodes. So a pod can span multiple nodes. It contains storage resources. So say you need to share storage between containers. You can connect storage, SMB shares or NFS shares to that pod, and it will be available to all the containers on that pod. And it also can have a network IP address. So if you want to send traffic into that, if it's a website, you want to hit HTTP, 10.1.1.1, and that's the IP address of that pod. It will be sent to one of those containers and served up. And it's managed by the kubelet. Now, deployment. How do we actually deploy these things? Once we've got a container cluster, how do we get our application onto it? Usually, best way is to have a deployment file, which is a manifest file like this. Usually, your developers or a third party is going to provide you with that. You can just look through it. It tells you things like, I want an Nginx image, or I want a SQL Server database image, container image, and I want 3 of them, and I want these ports to be hooked up. You really don't have to worry too much through this workshop of writing this. You just need to know that, be able to look through it, get an idea. You'll see what it does very soon. But it defines the desired state of your app. So it just says, look, my app consists of a database backend, a front end, and I want 3 front ends, and I want them running this image from the container registry. And you can modify that. You can change that config. You can actually change the content of that file. Say you want to scale it. Your front end's being hammered. You want to scale this up to 10 containers. Just change that file, reapply it. 10 containers get spun up by the master.
So this file is more how the service will run rather than each container, right?
Correct. It defines your entire application. Now, you might have a Kubernetes cluster. You might apply 10, 20 of these files that might all be deploying completely non-related systems. That's Kubernetes. You typically you're going to have a Kubernetes cluster running lots of different systems because it needs 4 virtual machines to make one application available. And then finally, this is the last concept we need to externally available to the internet. So a service is how you generally say, I want an IP address bound, a public IP address bound on this. And we're going to use one of these to make our application highly visible to everyone in the room. So one final thing, kubectl. Kubernetes is all console driven. There is some great visual tools, web-based tools that you can run. In fact, Azure Container Service deploys it with it. Deploys your container cluster with these tools installed, and you can just use it. But I want to stick with the command line. There's some other reasons you need to put SSH keys, but so won't worry too much. But we're going to be using this kubectl to control our cluster and spin up our app. So last bit, Azure Container Service deploys an unmanaged container cluster of type Kubernetes, DCOS, or Swarm. We're doing this Kubernetes one. There is another thing you'll come across called Azure Kubernetes Service, and that is a managed Kubernetes cluster, but it's in preview, and I didn't want to use there's still some challenges with that, but that is going to be awesome. That will take over ACS. When you deploy your ACS, you'll see a bunch of virtual machines, you'll see networking, you have to worry about it, you have to, if you stop a VM, to patch it, you have to do all the patching of the underlying container OS yourself. But AKS takes care of all of that. Basically, it says, Microsoft, you deal with it, I just want to run my containers. So you will see that once that goes GA. I'm not sure the ETA on that, but it shouldn't be too much longer. So ACS, it's self-healing, meaning if I go and try and break my Kubernetes cluster, Microsoft will do what it can to bring that cluster back in, that node back into my cluster. You can scale, so you can just say to the ACS in the ACS config, I want five more nodes, and it will scale those out for you, build those VMs, and put them into the cluster. There's things like service discovery and load balancing, automated rollouts and rollbacks. There's a whole lot of features. I love the secret and configuration management. That is really cool. Wrong button. There we go. So you can control your ACS using the portal, using resource manager template, all that stuff that Aiden was doing. All do it in resource manager template. I'd recommend if you can, but we're gonna do it in the CLI. Cloud Shell. You can also do it PowerShell. You can do it anyway. I mean, it's Azure. You can configure it how you want. You can set it up how you want. So the deployment options you need to set when you create one of these. You need to pick your orchestrator. So Kubernetes in our case. Remember that line you all ran before, and I had such trouble copying and pasting. All that did was set all those things. I set my orchestrator type to Kubernetes. I set my DNS prefix to Dan's ACS, and you've all set it to something else. I set my master credentials, which I'm using SSH. We won't go into too much detail, but SSH is, I don't use a username and password for authenticating to Kubernetes. I use a username and SSH key, which at the AZ CLI actually helpfully created for me. I specify the number of master nodes and the number of agents I want, and I can also specify the VM size. So if I want to run some massive SQL servers, and you can run SQL servers on these, if I wanted to run some SQL servers on this box, I might put a lot of CPU on them. So if you're interested, that's what an ACS cluster actually looks like. Don't even we'll go there for this session, but it's all on that GitHub repo. If you want to go into the PPT folder, you'll find this presentation. So this is what we should have now spun up. So that's the end of the presentation. Now we're going to head back over to the workshop, and let's see how you've all done on installing.
Failed.
Wow, that's you failed. Why did I succeed? Okay, so
You didn't copy properly or something?
hey?
Sure, I copied properly. No. I'm sure I copied properly.
One on batteries, reconnecting to the shells. I lost my error, but it's all the same thing.
Yes. Same here. I lost my error message.
I got it like a minute after. I got it in a minute after you got it. Okay. I put like trials and then after.
Same thing here. Yeah, I lost my error as well. Yes.
Some succeeded, others.
Oh, succeeded for some.
Yeah, no, mine was anyone who had a brand new Cloud Shell.
Yeah, brand new.
This everything's trying to deploy to the US.
So some people got different. You guys got SSH issues?
We didn't move the previous lab. It'll fail.
Oh, okay. Actually, you seem to have provisioned. You seem to be
No,
alright.
but I don't have the process.
This one here. So you're basically this is saying.
I have the subscription is not registered to use this Microsoft Incurring.
You lose your error as well.
Run it until we figure out what the problem was. Otherwise, I'll get the same error. It's time consuming.
Yeah, no. I got a different error. I use this. My error is more common. I have a lot of error and that's what you get when I do it.
It seems like saying something subscription is not able to
Yeah.
I didn't know that. It's like stuff going on.
Yeah, there's some subscriptions like lockdown what you can and can't do in different data centers. And it's not that policy thing that you.
No, I didn't do the policy thing.
What I need is
Oh, okay. Yeah. That's what I did.
If you want to record it,
Well,
there you
yeah,
go.
crazy with that.
That's right.
Same era.
There'll be a lot of these throughout many global.
And the yesterday.
Yeah.
Oh, but it worked on that.
Don't we all love that?
Yeah, isn't that the point? And they'll like standardize and run this.
Yeah. Across everything except the
Yeah.
Okay, so you're good.
You're good.
You got the register.
What you did?
Microsoft.network.
No, it's like the same era as you when deploying this current plan. So, but a few
Alright, there's a lot of troubleshooting going on at the moment, and we've got Dan and Nick and Aben, so there's about 3 going around and helping to try and make sure that the script is running and that it is deploying the containers. So I'm sure this will be happening through a number of different global Azure boot camps throughout the world. Is the best you can do, and you can try to get it right. But there will be issues. You know, I think we're into the practical side of it.
EU, quota limits of they've got including quota limits. Maybe this is your schema.
Yep.
Okay. Look inside your resource Oh, we follow along with next. Did you see a policy on your Oh, because have you seen this one before? Seeing the quota limits before.
You must have something else in the subscription. This is your day-to-day.
Not day to day. It's my test environment. So I have created 2 VMs with high CPU.
So you've exceeded your quota limit on CPU.
Yeah. So I can just turn off those 2. Yep.
Right, you were good. Anyone else good? Okay, who else was bad? You got the networking stuff. So okay. Do you
Yeah, like your cloud shell is still off. You need to reset it once.
Oh, you unless you got right. Yeah. Now, go to
If that didn't happen,
only want Microsoft. So this would have an internal installer.
Yeah, looks like it's working.
Yeah, so we're definitely into the workshops now. And practical phase. We'll end the stream there. We'll check in with our next session in about half an hour, 40 minutes.
Yeah, okay. Yeah.
So what about established
Yeah, that's. Which one was? Yeah, which one was?